In this video, we're going to go through calculating the molar mass of several compounds. The first one that we're going to look at is KMnO4. And I'm going to put the work on a separate page just so I have a little bit more room. So this is asking for what is the molar mass also sometimes called the gram formula mass. What is the molar mass? And so our first example is KMnO4. The way in which we calculate the molar mass of a compound, the mass of 1 mole, is we list out each one of the elements in the formula. So once we list out each one of the elements in the formula, now we need to identify how many of those elements there are. So there's 1 K, 1 Mn, and 4 Os. Once we identify the number of elements for the number of atoms of each element, now we go to our periodic table to find out the average atomic mass. And in our class, we're going to be rounding to the nearest tenth. So K is 39.1. Mn is 54.9. The next number is less than 5, so I would not round this 9 up. It stays as 54.9. And then this is 16.0 for oxygen. So it's like we're going shopping and we've got 1 K that costs 39.1 grams and 1 Mn that's 54.9 grams and then 4 O's that are 64.0 grams. So when we put this into our calculator, we've got 39.1 plus 54.9 plus 64. That gets us a total of 158.0 grams. What this means, the way we interpret this, is 1 mole of KMnO4 is equal to or equivalent to 158.0 grams of KMnO4. And if we wanted, we could also add on that it's also equivalent to 6.02 e to the 23rd. And now we'd have to decide, what are we going to call these? Well, this K is a metal, and this is a polyatomic ion. And so we're dealing with ions. So it's an ionic compound. And so we would have to call these formula units of KMnO4. Now, we would not be able to put the equals 22.4 liters because the 22.4 liters, that fourth piece, only works if you're dealing with a gas at standard temperature and pressure. So because we're not dealing with a gas, we cannot add that last piece in. Now, technically, this worksheet is asking only for the molar mass. This piece here is the molar mass, the mass of a mole. But as we found out, the equivalent statement can also be written for the 6.02 e to the 23rd, since that's also a mole. But we can't write the fourth piece of 22.4 liters because this is not a gas. The next example I would like to look at is question number 5. Question number 5 gives us the formula Al2SO4 3. So question number 5 is Al2SO4 3. So what I'm going to do is identify the number of atoms of each element. So Al, there's 2. S's, there are 3. And O's, there are 12. And the reason for each is there's a 2 that goes with the Al. This 3 is connected with the S as well as the O. So Al rounds this 26.9, but the next number is a 5 or bigger, so it makes the 9 go up, which makes the 6 go up, so that's 27.0. The S, 32.0, but the next number is a 7, so makes that 0 turn into a 1. We're rounding to the nearest tenth for this class. And then oxygen we've looked at earlier is 16. So this gets us 54.0. This gets us 96.3. And this 12 times 16, 10 times 16 would be 160. And then 2 times 16 is 32. So I think that's 192, if I'm not mistaken. 12 times 16, I believe, gets us to 192. So 192 plus 54 plus 96.3 gives us, I must have made a mistake, 192 plus 96.3 plus 54 gives us a total of 588. That can't be right, so I must have made a mistake again. 192 plus 96.3 plus 54 gives us a total of 342.3. 342.3, and that is equal to the grams. Those atomic weight gives us the grams. So when I write this out, 1 mole of Al2 SO43, 1 mole of Al2 SO43 is equivalent to 342.3 grams of Al2SO43, which is also equal to 6.02 e to the 23rd. And we got to decide, are we going to call these atoms, molecules, formula units? Well, once again, we have a metal. The way that I know Al is a metal is it's located to the left of the stair-step line. And then we have a group of nonmetals. The SO4s are nonmetals. So anytime we have a metal and a nonmetal, it makes an ionic compound, and we have to call them formula units. They do not make molecules. And it's formula units of Al2SO43. Anytime we have an ionic compound, it is a solid. It is not a gas. So we cannot put the equals 22.4 liters. Technically, this piece is the molar mass. When they ask us for the molar mass, it's the mass in grams of a mole, and that's the molar mass. I hope this helps in understanding how we're going to write out and calculate the molar mass of a compound.